My guest today is Arthur Doler. Arthur, how are you today?
Doing great, Dave. How are you?
I'm doing really well. It's a beautiful day here in Chicago, and I just got inside from enjoying the sunshine and the fall weather.
Nice.
Let's tell me what you do for a living, Arthur.
I am a software developer and the community and culture steward at Aperture, which is a software consultancy in Omaha, Nebraska, which is where I live. And I've been there 11 years in March.
You've been a
So
consultant at this company for 11 years.
yes, and
You've
that
probably seen it
means
all.
yeah, actually, the way I usually like to say it is people don't come to consultancies and say like, hey, we have a couple spare $1 million in this really cool app. Do you want to come play with us? They're always coming with, this broken thing that's just shattered. It's like, can you please put this back together? And everybody that's touched it before has just left it worse, but you have to go fix it. Uh,
Is it
so
fair to say that most of what you're doing is working with what I call brownfield applications as opposed to creating something new?
yeah, it's more common that you come up and there's at least an existing solution that you're either patterning off of or extending because companies don't want to waste money on, hey, you need to upgrade to the newest, hottest thing just because they've got the money, again, just they don't really have that money laying around. They've got it for other purposes.
Okay.
So most of the time it's, hey, we want to do this mobile app on top of this existing stuff, or we want to, hey, it's like people augmenting and refinishing their house, where it's, hey, we're doing a renovation and we want to re-up the bathroom and make it cooler. They're not usually coming in and like, we just need a whole new house. So most of the time, you're working with some other code that other people have written.
And there are
Uh,
challenges to that, aren't there?
oh well, of course. Starting with that, all other developers are stupid, and
Not you and
there's
me, of course, but
no, of
all of
course, we're perfect. And I would never be the person that, you go look at what idiot wrote this, and 6 months later, it's like, oh, it was me. Never happens to me at all. Uh, but that kind of takes me to what I've learned throughout this job, which is that most of the time, even the default response is you just want to go, what idiot wrote all of this? This is nonsense. They're doing this over here, and this thing is wrong, and this thing is crazy, and that this piece does not make any sense. Uh, and there was actually one project specifically at Aperture that I worked on that was we'll call it a bingo game provider. So a gambling thing for bingo, where you could make these bets on, what balls show up and
Hmm.
potentially win. And this, they'd started writing pieces of this app before I'd graduated college, which I'm not very young. I graduated college in 2003,
You're a
just to give you an
kid.
idea. Yeah, I know. It just gives you an idea of how old the app was, though. And I think one of the moments that really, like the architecture of this app was absolutely ridiculous. And I got to a point where finally I understood that they'd written this piece of code in C and they were multiplexing over these file descriptors. And it made, for these network connections, it made no absolute sense why they just weren't using sockets or something, sane to work with these pieces, like this actual network connections. And it finally realized over the course of this that that piece of code had been written back when, well, the way they run it is there's a parlor and then they stream the results to local bars that you can bet at these local bars, like pay money and bet at the bars and see if you win. And there's a TV screen showing the results. Um, and they turn around and back in the days when this was written, all of those places used to connect to the parlor with modems, like dial-up modems. And so it actually made sense why they were doing what they did with this architecture, because of the way that these actual connection interfaces were supposed to work. So that project taught me a lot about understanding other people's code and really understanding what I've come to call code archaeology, which is understanding that other people wrote this code to serve a purpose and for a particular reason. And the purpose, like the practice of looking at an artifact and saying, hey, some human built this for some reason. Let's figure out what, is called archaeology. And so I've been trying to teach that. Like, it was a thing I've had to learn, kind of School of Hard Knocks, and it's a thing I've been trying to teach to others at this point. So
It's interesting. This archaeology or code archaeology that you're talking about, it's a phrase that I really hadn't heard before, but I actually heard it twice in the last week. So I think is there a lot of interest in that right now? Is that topic? Am I just been out in the dark, or has this been around for a long time?
There's definitely some appetite for it. It was something that I thought about kind of as a isolated thing, but other people have come up with the same concept of, digging through what feels like years and decades of muck to get to the understanding of what's going on with these artifacts that are going around. I mean, realistically, right, the most of the code you encounter in your life is code you didn't write.
Right.
It's just how code works.
Sure. Yeah.
And
It doesn't make sense, really, just to rewrite something just to rewrite. There has to be some value in that. And oftentimes it makes sense to fix what's broken rather than to throw it away and buy something new. And so, not
yeah,
always, but, and even if it doesn't make sense, people are reluctant to throw away sunk costs. They want to fix it, they want it to work.
certainly at the product owner business level, right? I mean, developers are often like, let's rewrite
Let's
everything
play
in
with
the
something
newest.
shiny and new.
Yeah. But it's real hard to get your product owner or your manager to say, yeah, it's okay, replace the entire app. It's fine.
Yeah. Well, but that's from, you mentioned the developers that they have a different mindset. How do I get into this mindset of being able to do this archaeology that you're talking about?
The first steps are really to cultivate curiosity and empathy. Because when it comes down to it, the person who wrote the code that you're looking at almost certainly did not want to write terrible, awful code that doesn't scale.
Yeah.
Uh, I've been a developer for 20 plus years at this point, and I have come across very, very few developers that just do not care. Most of us care about our craft. Most of us, I mean, not just most, I'm going to say almost all developers care about their craft and want to do good code, want to write good code. And the fact then, if you ask a question, okay, so why is there so much bad code? And a lot of it is like, well, some of it wasn't bad when it was written. Some of it was
Mhm.
perfectly fine. But on the other hand, sometimes people just don't have time. You're not given enough time to write the thing. You're forced into a position where you're juggling two different things, and your boss says, well, get it both done. And you're like, how? I can't be two people. And they don't care. Or you're forced into doing some weird nonsense business thing because of arcane business decisions where you have to use this thing because we made an agreement with this company and you will use this. Doesn't make any sense for our purposes. We don't care. Okay. So, the ecosystem of programming decisions is so much larger than are just the writing of the code. And so having that mindset and thinking back to the points in time of when you had those situations, right?
Sure.
Where you were forced into something and you knew was stupid in the moment. You had to do it because you didn't have time, or you were told that that's the way you had to do it and you couldn't fight it for whatever reason. So that level of empathy to the person who wrote this code, and also just curiosity and asking, forcing yourself to ask why over and over and over again. Like, why is this way? Why is that way? Why did they do that? And not in a like, what idiot does that sense, but actually genuinely asking, why? Why was this written this way? Because this is not how I would expect it to have been written. And then doing the legwork on it.
Let's talk about the
So,
legwork. What's step one? Now that I've come to the conclusion that maybe everyone else is not an idiot. Maybe they had reasons for doing the things they did.
yeah.
The golden triangle, I think, came to mind when they said there's.
Hmm.
I can do. I think it's called the golden triangle. You can have
Oh,
it
the engineering, yeah.
fast or high quality or what was the other one? I forgot.
Cheap.
cheap, faster,
Yeah.
or good.
Cheap, faster, good.
That's great. You can choose two of those, but you get to choose.
I've heard that called the engineering triangle. Yeah. But
So
that's
you
only
come
because
to
I
that
haven't used it.
conclusion.
Yeah.
We need to address this. The code. This is the way that it is. We are going to work with it. We've accepted that. Where do we
Well, the
start?
first thing to figure out is, why does the app even exist? What is its purpose? What does it do? Because especially if you're working in some kind of enterprise architecture context, like that's not always obvious. What is the purpose of this piece of code that we're looking at? And I have a technique that I've developed over the course of having to look at some of these systems, and it's really you look at three different things. You look at the humans, and then you look at the code or the system, and then you look at the code.
Okay.
And I actually look at it as an hourglass where you start with the humans, move to the system, then to the code, and then back up to the system and back up to the humans. So you're kind of going from broader scope down to narrowest scope and then out to broadest scope again. And the first thing to do is start with the humans, right? Sit down and just ask yourself, okay, who are the people that use this app and why are they using it? What are they trying to do with it? What are their goals? What are the types of people? And so, for example, with the bingo thing, it might be, okay, you have a player and they want to play bingo and win money. They want to bet on numbers and get things back. Um, then you have the bingo writer, the person at the bar or the parlor whose job is to actually like punch the ticket into the system. And they interact with the system in a very particular way of, hey, somebody's told me they want this ticket. I want to put it in. I want to know how much it costs so I can tell them to get me the money and get the money and then print the ticket and hand them the thing. If that starts sounding like user research, like user experience research, it is, because that's basically the work of it. If you don't have a set of here's who interact with this and here's why they're interacting with it and here's what they're trying to get done, then it's really hard to understand why that app even exists in the first place. Right. And it doesn't have to be, and this is true for all of the things I'm going to say, it doesn't have to be correct out of the gate. And in fact, it's best to start with the assumption that it will be wrong somewhat, because you're going to find things out as you go through the code. You're going to find goals for user roles that you like, oh, wait a minute, why is this code this way? And then it bubbles back up and you have to ask somebody and they'll say, oh yeah, because this person wants this specific way, and they get really pissed off if it's not. Suddenly you've got a new goal to go add to this list of this user wants this in this format. So it's going to be wrong to an extent, and not treating it as the global, sacrosanct, this is the correctness when we start, helps you get in that mindset of growing and learning what the system is doing.
Absolutely. You need to understand the functional requirements, and that user interface is a huge part of the functional requirements.
Yeah. So then you move on to the system of starting, okay, we have a particular thing, and that could be usually it'll be something that's picked for you, right? If you're starting on a project or you're pulled as a contractor, somebody's going to hand you a thing and say, fix this, make this, do that. So you've got usually a goal to start with. You kind of go, okay, what system part do they interact with first to start that? So in the case of if I'm doing the bingo thing, if I'm a writer, it's going to be with this terminal that's sitting in front of me. That's the first thing I interact with. So that's the first piece you start with of going, okay, this is the system. And usually there's some degree of first getting all of the list of the things in the system together of like, okay, these are all the pieces that I kind of understand, and connecting those together, which is basically architecture of the system. But usually we think about the architecture as being defined for us, as like somebody's defined this architecture and here it is. When we took over the bingo application, I think our first glimpse of the system architecture was literally drawn on a napkin, and handed to the project manager, just to give you an idea of, how well documented that system was. But again, you want to have that assumption of this is probably wrong. There are probably simplifications that have been happening. Humans do that naturally, of just kind of rubbing off the rough edges and understanding, oh, this is how this works, and describing it that way as truth, when really it's this more complicated process.
Of course, yeah. It makes it easier to keep things in your head if you're simplifying them.
Yeah, I mean, that's how abstractions work, right? So moving through that, then you start with, okay, let's go down to the code. Let's start with the first system that they're interacting with, the first subsystem, the first piece of that architecture, and literally just start walking through it line by line, moving through and understanding, okay, so they're going to go from here and it's going to go over to this method and it's going to go to this method. And from that point, starting with really just tracking, okay, it's going to go call the database here. You don't go over to the database at that point. You just note, hey, this thing talks to the database. Okay. And moving on from that point, so you kind of have an idea of the flow through that one piece. That's the code section of the hourglass. And then you move up to the next level of asking, okay, now I know what this flow is. Where does that go from there? And now you go look at what the database does and try and flow to these other systems. Basically follow the flow of control architecture, or flow control, through these subsystems, down into the thing, back up into the thing. So the tool I generally recommend for that is actually called an execution flow diagram, which is an old UML level tool, but they're really helpful for this specific use case, because they help you understand what the flow is between those things. This thing is calling this other thing. This thing is calling this other service, and this service is calling the database. Then it comes back up to here, and then it calls another to the database to do it something else, and then it comes back up over here. And it just helps you get your brain around all of it.
Okay. So I think that this whole survey section, I think you called it, is it comes down to understanding the system, understanding what are the users, who are the users that are using it, how are they using it, how does it internally execute on that,
Yep.
do these requirements that the users expect at first at
Well,
a high level and then at a lower level in the individual components.
yep. And the last step is the humans again, of going back up and saying, okay, well, here's the result of all of this that I've walked through. How does that mesh or not mesh with the original goal of the human that interacted with it? And if you're being told, hey, this is a bug, or hey, this is a thing that needs to improve, that'd be where you go, okay, I don't, this is different. So now I see what the differences are. And a lot of people stop at that point. And honestly, if you do stop at that point, you've still done a lot of work to understand kind of what the system is. But there's a lot more that you can do to understand why the code is the way it is, which is really that the next step, which is what I call extraction.
Okay.
And extraction is, so surveying in archaeology is when they do those rope lines, the twine lines, and break things up into squares. Mm-hmm. And then they understand, okay, this is what the lay of the land was, and this is where these major superstructures are located. And then the extraction is the part where they start digging out individual squares.
All right, I like this metaphor.
Yeah, right? And that's the digging down into the dirt, into what they call the matrix, which is a fun name, but it's the dirt and junk surrounding these artifacts is what they call the matrix. And that, for a developers, usually looks like history, going into history. And there's a couple different kinds of history I talk about. The first of which is just documentation, written history, right? What's documented, what's written down, what's the understanding? And I mean, there's it's almost certainly wrong, right? To at least some degree.
Because maybe it's out of date would be a good reason for
right.
It. Maybe it was right at one time.
Exactly. Or maybe the person who wrote it was tasked with it, an intern that got tasked with the terrible job of documenting and couldn't move past
understand it in the first place.
Yeah. So you've got the written history, right? But if you don't have that, there's still other histories. One of the ones that I think is undersold is oral history. If you go ask other people on the project, if you have access to them, of, hey, what about this piece of code? This seems really weird. What about this piece that I'm not understanding how this fits together? A lot of people who've worked on the project, I mean, developers over time will build an internal mental model of the code, right? And especially if they're the person that worked on that thing, oftentimes they will remember, or you can get them to remember, oh, that's right. This thing is weird because X, Y, and Z happened in this other weird case, right? Once you dig them through their memory and get them to tell the stories. Past that point, though, there is actually, what's the fourth kind, or third kind, rather? Well, there's external history as well. And external history is history that is kind of foisted on your project.
Okay.
The method I think about, what I think about it is, when you use a library or a framework, that shapes the code that you write.
Sure.
Especially if it's something major, like say Redux on the front end as a piece of software, because Redux has a ton of boilerplate and a ton of this code that needs to
very opinionated.
Right. And so there's a bunch of code that you write that is specifically for Redux and for operating within Redux. If you find code that looks like that, even if they're not using Redux, it tells you something about they did use Redux in the past.
Right.
And those legacies, things like MVC, will shape the code that you write and can tell you a lot about what's going on or what used to happen with that software. Past that point, you can actually turn around and start working to understand, through reading the code, the people that actually wrote the software. So if you have access to Git repositories, that you could dig into and start understanding through the version control history, the changes that have happened, especially if they've written good commit messages and not just, trying this thing.
Wait, so I think we're in the next phase here. There was
that's history.
Still an extract.
Yep.
Okay.
Because Git stuff as well is also still your history.
Okay.
But most importantly, if you have usernames, you can start tying those to individual behaviors. And that lets you know something about the people that wrote the code,
Oh,
in the sense of, okay, if I look at this person's code and I'm seeing the commits they make as I go through, I can get a sense of their taste as a developer, what they
mm,
prefer. And that can tell me things about when I see things that don't mesh with their taste, that tells me something. It tells me that there was some external constraint, whether that
okay.
was another person or it was, oh, they couldn't do things the way they wanted. They had to do it this way.
Yeah.
Why? What is true of the environment in that moment?
Right. Could have been development standards, or could have been just state of the art at the time. Maybe they
Yeah.
evolved how they do things.
Or it could have been like, oh, we had to do it this way because we were interacting with this particular library or
Right.
database that only had this data in this particular format.
I see. Okay.
But
Okay. So I
so
think we've covered extraction. We covered survey and extraction. What's the next step?
the next step is analysis. So you've got a bunch of data here, right? You have how the code works, you have how it should work, you have the history of that code, hopefully, of how the changes that it's been through over time. And then you sit down and start asking yourself, okay, what else can I know about this? What can I learn about things like the strata in the application? So there's an application I'm working with right now that has still running and active ASP, like Visual Basic ASPX code, a backbone layer, like Backbone and Marionette.
Okay.
If you remember, that was the hotness for a little
There's a
while
name
there.
I've not heard in a long time.
Yeah, really. Still running. Uh, there's JavaScript, Redux code, and then the most recent layer is TypeScript, React, like Tanstack query. All of those are running concurrently as different deployed projects as part of the stitched together web app. But it tells you something about the history of that project and what it's been through. And if you find a piece of code and somebody says, oh, yeah, that's in web app, which is the ASPX one.
The front
Oh,
end.
okay. Yeah, well, there's the React front end,
Oh,
and
and then
then
there's the code
there's,
behind.
yeah, and well, there's actually two running websites that are stitched together through some shenanigans that they've got.
Hmm.
Um, it's a thing, but it works. But knowing that this code exists in that ASP, like the Visual VB ASPX layer, tells you something about when it was written, probably, and tells you
Okay.
something about what the standards were at that time, like
Hmm.
what was normal. So then considering things like what are the external forces operating on the team at that time, if you can find out, talking to people like project managers, talking to people like product owners, and asking questions about like, so when this happened, what was happening to the team? Did they staff it enough? I mean, which never happens, but did they have enough people? Were they under fire from this other thing? Did they have to get this done because the client was threatening to leave, kind of sort of like thing? That level of understanding what's going on from there. And then you tell then now you really have the full story of this is what the code is, this is what it should be, this is how it got there, this is who got it there, and the circumstances surrounding it. Once you have that, it's then ready for the next step.
Which is
The next step is progression, like to do something with it.
so.
Uh,
Wait, so well, let me hold on a second.
yeah,
So this is this whole getting in the right mindset, doing your surveys, getting your extraction, doing your analysis. All of this you'll do on any legacy project like this before you start actually modifying the code. Is that a true statement?
yeah, with
Okay,
one
interesting.
exception, and it's a thing I didn't mention, but I do want to mention here. Philiane Ermans wrote a book called The Programmer's Brain, and one of the things she talks about is refactoring for understanding, which is as you go through the code to make it easier to read, to make it so that you can understand the code better, just refactor it, change it.
Right.
You can don't commit it, or maybe commit it to a private branch, but don't push it back to develop or whatever.
Hmm.
Instead, just do it so that you understand the code better. With that caveat of you've made maybe some changes just to help you understand the code a little bit better. Like for instance, if you run across a really thorny nested ternary and you're not so great at ternaries, speaking for a friend, but it might be easier for you to read that as an if-else chain, even if you're not going to commit it back to the code as an if-else chain.
I see. See if it works the same.
Right.
If it changes anything. See if those unit
What?
tests still pass, assuming there are unit tests.
Well, yeah, and it's not even a question of, okay, I'm going to change this and make it prod. It's just, oh, it's easier for me to read this way, and that helps
Right.
you understand it.
That's right.
So, but yeah, then at that point, everything up until this point has been understanding how you're going to, like, how the code got the way it is. Because if you understand why the code is the way it is so much easier to change the code without running into regressions, without running into problems, or deciding to rewrite the code. If you encounter a place, and we've been on some projects before where we hit the end of this understanding process and we looked at the customer and we're like, sorry, friend, this is a teardown. Like, we're going to have to go to the studs on this one.
Right. Maybe just for that section of the application.
Yeah, because it just needed all of that work. If you try to do that without understanding, then you're just going to run up against all of the situations that are still true that you don't understand. Because sometimes they made a thing this way and they did it because it was true back then and isn't true now, right? Sometimes when you rewrite, though, you're going to encounter those times where all those things are still true. You just don't understand them. And so you're going to see all of those things as this endless stream of user acceptance failures and bug regressions after you ship the app, because your users are going to go, wait a minute, you didn't take into account this case on alternating Thursdays under the full moon.
Exactly.
So doing that legwork beforehand helps you get and understand that part better and do better refactoring.
Yeah, I think so. I was a consultant for many years, and I worked on a lot of legacy code. And I think I did most of the things that you talked about, but I don't think I was conscious of them. And the fact that I wasn't conscious of them probably bit me a few times. Particularly the part about not understanding the business rules, and particularly the edge cases, the ones that were not explicitly articulated or explicitly documented somewhere, the people had just forgotten about. Because of course the system does this when that happens every 6 months, and then when
Exactly.
it doesn't, they're disappointed or angry because I didn't make this. My job was, and sometimes that frustrating. You get the frustrating requirements like just make the system do the same thing. Fix this thing, but don't break anything.
Yes.
Well, what do you mean by anything?
I've literally had those conversations with clients about they're like, just do exactly what it did before, but in a different language and framework. I'm like, no, that's not how.
We're not going to tell you exactly what it did before.
Just make it do exactly. Yeah. But that's we can't feasibly talk to every user at a company that's 100 people large. Right. If everyone's using that software, you can't do a user interview with all of them. It's just unreasonable. So you're going to miss Carol, who cares about this one report 2 times a year,
right.
And everybody else has forgotten that this report even exists in the application. So this process of really digging through and understanding that flow, and like I said, building out who are the people in your software and what are they trying to do, helps you understand how to change it and change it safely.
Arthur, we're just about at time. You mentioned The Programmer's Brain. I looked up on Amazon, that book, and I'll put a link to that in the show notes. Are there any other resources you can recommend to folks that can help them to understand this better?
Yeah, I will get you a couple links on things like execution flow diagrams, things like actually some resources for refactoring. There's always the classic Fowler refactoring book, Martin Fowler. There's Michael C. Feathers, who I understand you've had on your show.
Yes, nice fellow. I got to speak to him at length.
He
wrote Refactoring Legacy Code, I think is the title of his book.
Yep, working effectively with legacy code.
Working effectively, thank you.
Emily Bashi, I think I'm pronouncing her last name right, on YouTube has a couple different refactoring videos that if you're more a fan of the video format, I found really interesting. And there's also Refactoring to Patterns, which I recommend without having read, but people that I trust have told me it's a good book.
Awesome. Arthur, this has been educational for me. I really appreciate your time. Thank you.
Thanks very much, David. If you're practicing code archaeology effectively, not only are you going to build better technology, but you can actually make friends with developers from the past that you never even met.